We are graphing systems of equations today. Based on our little preview activity, I've got one line here and another line here. Whenever you have more than one line, we call that a system. Okay? So what do you notice about 2 by 2 systems of equations? Here's my first line that I graphed. We were talking about quarters and dimes. And here we were talking about how many quarters and how many dimes would add up to 90 cents. How many equations do we have in this system? Thank you. How many variables are in this system? Some would say 4, but really there's only 2, x and y, right? Or our quarters and our dimes. And how many solutions do we have?
1.
Okay, I'm going to say it again. So when you have an intersection, we call that a solution. Can you have more than one solution if you have 2 lines? Think about that. What do you think? I've got some people are saying yes, some people are saying no. Draw a line with your arms. What happened? One solution. Can you go like, you'd have to like bend your hands back in order to find another one, right? Is that a line when you bend your arms back? No. That's a different type of equation, okay? Specifically, that would be a quadratic equation. Okay, so pencils down. Pay attention. If I see you writing, Josh, I'm going to take your paper away. Okay? All right, so based on what you know about lines and intersections, let's start with you, Josh. How would you interpret the following and why? Take a look at that. Let's give everybody a chance to look at it first. Okay, Josh, pick one. The middle one. Okay, what can you say about the middle one? They're parallel, therefore, no solution. Why? Can you tell me why? Because they'll never intersect. Right? How can you have a solution if they never intersect? They have no common point. Right? There's no common point between them. You can't say that they have something in common. All right, what about somebody new? Yes. Go ahead. Oh. Okay. Go ahead. Which one's infinitely many? Why? Because there's no other line, right? There actually could be. What if I told you there's a red line underneath that blue one? Still the same line, right? What about a blue one? Oh, it's blue. What about a pink one? Would you believe me? There could be. It's kind of like cars. If I'm in traffic and there's cars in front of me, can I tell how many cars are in front of me? No, you can't specifically say. If it's a straight line in front of you, you can't figure it out unless one's higher than the other, right? Especially if you're a smaller car than the one in front of you. All right, so what about this last one? One solution. Good. All right, pencils down. So I'm going to solve this system of equations by graphing. I want my blue back. There we go. All right, so I don't need to solve for y because they're already in slope-intercept form. So based on this equation right here, I'm going to say, all right, I'm going to start at 6, and I'm going to go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. I could also go down 1 over 2, down 1 over 2. I want to be nice and accurate, but Jesse, I don't want, not Jesse, Michael, I don't want you drawing yet, okay? Just pay attention. All right, so there's my first line of my system. Let's change it to red or green? Red, okay. So I'm going to begin at -7. And I'm going to move up 7 over 1. 1, 2, 3, 4, 5, 6, 7 over 1. Go again? Might as well. 1, 2, 3, 4, 5, 6, 7, 1. Bingo. What did I just find? I just found my solution. Most of you should be saying, this is easy. Because all of you are pretty good at graphing. So there's my target, there's my solution. Let's name it. What's my solution? Remember? My house is right here. How do I get there? What do I do? To the right 2 and up 7. There's my solution. All right, go ahead and copy that one down. We solved for y. That was already done for us. Graphed our equation. Named our solution. This solution happens to intersect. Okay, you guys go ahead and start this one on your own. Once you've got it solved for your solution, go ahead and check with your shoulder partner and then put it into your clicker, please. Okay, let's see how you guys did. Fantastic. One person got B. Let's see why. So, thought it was a negative? Okay, let's do this together. So, I start at 2 on this one. Let me change my color. Start at 2, and I have to go up 1 and to the left 1. Parent graph, right? Parent graph only translated up 2 and a negative 1. So there's my first one. I'm not understanding why we got the wrong answer on the other one. So here's 5. And then up 1 over 2. Up 1 over 2. So negative 2. Positive 4 is our solution, right there. So how would you get, oops, wrong one. How would you get B? How would you end up down here? Just press the wrong button? Because I don't understand how you could get down there. Okay. All right, good job, guys. I'm going to start this one for you. Pencils down. All right, so this time I need to solve, correct? Which should be pretty easy for you guys. You guys are pretty good at this. So I get y equals negative 2x plus 4. Let's graph that.
Minus 4.
Minus 4. Thank you. So I go down 4, and then up 2 and to the right or the left? Left. Up 2 over 1. Go ahead and graph that line. Didn't do a very good job of that one. Let's move that over a little bit. Alright, fantastic. Let me change my color to red. On this side, if I subtract x from both sides, I immediately tell myself, oh, this is also a negative slope. How can we have two negative slopes and they intersect? What would be the only way that they would not intersect? I heard it. They're parallel, right? Okay, so I'm going to graph this one. I'm going to start at 4, and I'm going to go up 1 and to the left, up 1 and to the left, up 1 and to the left. Oh, I didn't divide yet. Y equals negative 1/2 x plus 2. That makes a difference. So I need to start at 2. And up 1 into the left 2, up 1 into the left 2. Now that line didn't exactly cross there, but can you see that my line isn't quite perfect? So it is helpful to use a ruler on these guys, right? Okay, so I'm going to go ahead and graph that one, and that was equally horrible. Better? Kind of? Still not satisfied, Levi? Okay, what's my solution? Where do I have to go? -4, +4. Go ahead and write that down. And try this one on your own and put it in your clicker for me. All right, let's see how you guys are doing. 15, perfect. Fantastic. A couple people didn't get the right answer. Let's look at this. All right, y = 4. I'm talking about y, correct? Is that already S? Nope, that's not S. We got 11, so it's not our bell yet. It's not 11:14. Okay. So I'm talking about y. So do I need to touch the x-axis? I'm talking about y. So where am I going to go? I'm going to go up to y. Right here. And I'm going to graph it. Right there. Then I'm going to come over here and I'm going to say, okay, well, I need to put this into slope-intercept form. So what am I going to do? Solve for y. Subtract 8x from both sides. And I get 3y equals -8x minus 12. What do I do next, Michael? What do I do next? From here. I'm solving for y. Can't subtract because they're being multiplied. Divide. Divide everybody by 3. And I get y equals -8/3 x minus, what guys? 4. Perfect. So I'm going to start at -4, and I'm going to rise up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go to the left 3. 1, 2, 3. There's my point of intersection. That was easy. Right there. There's my point of intersection, which is at -3, 4. Question. Try this one. And let's see how you guys did. Excellent. So, just like Lauren said, the slopes are the same. Lauren, did you have to solve for y to figure out they were the same? No. How could you just look at them and say it's got to be the same slope? Can you look at it and just tell me that? They both have coefficients. The coefficient of x is the same, and the coefficient of y is the same, right? So slopes are going to have to be the same. All right, but when I solve for y, I get -4x, -3y, I should have changed my color, is -4x plus 9. Divide both sides by -3. And my first line is going to be y equals +4/3 x plus, -3. And my second one, I'm also going to subtract 4x from both sides. And I get -3y equals -4x plus 3. So what's the difference between these two lines? Can you guys describe it to me? One of them is shifted up 1, and one of them is shifted down 3, or translated down 3. Same slopes, though. So if they have the same slope, then we're going to have no solution. 1, 2, 3, 4. 1, 2, 3. Did I do something wrong? Where? Positive 1? It should be negative 1. You're right. Thank you. Negative 1. 1, 2, 3, 4. 1, 2, 3. Did I make another mistake? No? 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. All right, guys. Your homework is being passed out right now. Have a good day.